Fourth grade kiddos, it's Mrs. G. I'm going to take you through Module 2, Session 3, and we're going to work through some perimeter problems and area problems, not knowing the dimensions of a quadrilateral. So let's get started. Here are the learning goals. We are going to use you guys factors, multiples, and figuring out and working backwards to solve these problems. So make sure you remember. Here's one way we can remember what factors and multiples, even though you're not going to have this workplace. We did something similar to this at the beginning of fourth grade. Remember, factors and multiples. Factors are the numbers you multiply times each other to get to a number. For example, if we're working with the number 20, let's do 21. There are two factor pairs. There are four factors. There are two factor pairs we could use. We could do 1 times 21. So 1 and 21 are factors of 21. Or we could do 7 times 3, which is a factor pair. 7 and 3 being factors of the number 21. And just to remind you, multiples, really, when I think multiples, it's when you have a factor pair, it's the answer or the product of the two. But the way I do it is it's skip counting. So multiples of 7, are 7, 14, 21, 28. Those are multiples of 7. Okay, that's going to help us when we're working backwards, trying to figure out dimensions to unknown perimeter area problems. So moving on through the lesson, you aren't going to be in charge of, oh, that's fun. My smartboard isn't working, so I'm going to come over to the computer. You aren't working through that. Okay, so you guys, here's a problem we're going to work through. Obviously you can see one side is 13, but we don't know the other dimension. We do know, however, because we're super smart, we know the side parallel to the 13 inches is also 13 inches. So right now, we could fill in the unknown on the other side just knowing they're equal to each other or congruent. Okay, so let's read through this problem. PJ string rectangle problem. PJ is in the fourth grade. The other day, PJ's teacher gave her a piece of string that was 84 inches long. I'm just going to kind of note that. 84 inches long. That's going to be important. And asked PJ to make a rectangle with it. The teacher said to make one dimension of the rectangle 13. So that's the 13. That's this right here. That's 13 inches of the string. If we were to wrap the string all the way around this rectangle, it would come to 84. Okay. The teacher said to make one dimension and figure out the length of the other dimension. PJ got out her measuring tape and started to work, but was soon very frustrated. Every time she tried to arrange a string, it got messed up. She put the string and the measuring tape aside and decided to solve the problem by making a sketch instead. Here is PJ's work so far. What would you do next to solve the problem? Well, we already did a step. We already know, you guys, across from the 13 is going to be the same 13. So that tells us if we're working with 84 inches of a rope or a string, 13 plus 13 is 26. 26 of those inches are already used up. So let's do this. 84, take away 26. So you guys, left over, just figuring that out, left over, we have 58 inches left over. So I'm going to make sure I did it right. I'm going to add 58 plus 26, and I should get 84, which I did. So we have 58 left. So this can't just be 58 right here. This top one can't be 58 because we have a total of 84. So if we take 58 plus 13, we still haven't added this bottom part on. So what we need to do with the 58, because we only have 58 total to work from now, is we have to divide it in half. And when we do that, 58 divided by 2, that will tell us what this measures and what this measures, giving us a total of 84. So half of 58, 25, and then we still need 8 more. It's going to be 29. 29, is that correct? Yes. So you guys, this must be 29 inches, and this must be 29 inches. Now, if I added up all the sides, 29 plus 29 plus 13 plus 13, in the end, we get the magical 84. So we really have to think through this as multi-step. We're using, our half strategy. We're using the double strategy. We're dividing, we're multiplying, factors, multiples. We got it all going on. And again, it won't keep going. So I'm going to come back over here. So now you guys, let's look at what you're going to do in your student book pages today. Pretty much the same thing, less of a story, more just giving you a quadrilateral. And I think it looks like most of them are going to be rectangles, giving you one dimension and you having to solve the other dimension. So, and you got to be careful because I don't know if it's going to say perimeter all the time or area, but remember the formula for perimeter is adding all the sides. So, really doing this in the end, the formula, you're adding this side, this side, this side, and this side. But we know the formula as you're taking the height and doubling it, and then you're taking the length and doubling it, and that gives you the perimeter. Okay, so let's look at this first one together. You can have your student book open right now, and I'm going to work you through the first couple of problems. So the rectangle A right here, this one, rectangle A, the perimeter is 72. So you guys, I need this whole thing to add up to 72. So what can we do right away? Well, looking at 30 feet, we could put 30 feet here. We're very aware that those are congruent. They're parallel to each other. So you guys, 30 plus 30, that's 60 feet we already have taken care of. So I'm going to write that over here. 60 feet is already taken care of the 72. That's the perimeter. So in the end, we only have 12 feet to work from now for this side and this side. So what do we have to do with that 12 feet? Well, we can't write 12 here. That's not going to work because then this would be 12 and we'd be over on the perimeter. So it's definitely not 12. But with that 12, we know we have to divide them in half so that they can, they would add up both sides. So 12 divided by 2 is 6. So 6 goes here, 6 goes here, 6 feet. And so we're going to add them all up again. We're going to add all the sides up. 6 plus, well, let's do it the easy way. 30 plus 30 is 60, plus 6 more, 66, plus 6 more is 72, which gives us a magical perimeter of 72 over here. So dimension A, the unknown, this was B, dimension A must be 6. Boom, we did it. Okay, let's go down to the next one. I'll even just kind of move it down maybe. You gotta go over here. Okay, let's go to number 2 and look at it. And I'll move my work. Okay, number 2. Number 2, it looks like perimeter. Ooh, we're going big time. 738 is our number. That's what we need all the sides to add up to, or the sum, if you will. So the sum must be 738. But look at this, you guys. Dimension A, this one's 199 meters, so this one must be 199 meters. Okay, so that takes care of a lot of the 738. So let's double 199. I'm going to do 200 plus 200, 400, and then just take away 2. So it's 398. And you guys can kind of follow me. You can get there however you want. I just went the over strategy. But of the 738, I have used now 398. So again, I said these are going to be multi-step. They want you to really think about these problems. So 738, take away 398. I'm going to do it like this. Take away 398. I don't want to make a mistake. This is the easiest way for Mrs. G. You can get to it however you want. But I do believe 340. Yep, I do believe 340 is what we have left over. And again, we know 340 cannot go here, because then 340 has to go here, which is parallel and congruent to the one up top. So what do we have to do with the 340? We have to divide the 340 in half. So half of 340, well, half of 300 is 150. And then we have the 40, which is half of that's 20. So I think it's 170. And your brains are probably thinking through it however you want. But if we have 340 divided by 2, my brain, and I just talked you through how I got to it, but you can get to it however you want, is 170. So let's try this. You guys, let's put 170 up here. That means 170 goes here. And let's add those up. 170 plus 170 is 340, plus another 398 from this and this. And we, in fact, did it. We got the perimeter 738. Beautiful. Now you're going to work through the rest on your own. I will say sometimes, you guys, if you have to divide an odd number in half, your answer could be half. So what I'm saying is, if you have 25 left over that you have to divide in half and make a dimension, then the answer is going to be 12 and a half for each one, because that half will make the one. That's odd. Let's go to the next page. These are the problems I want you to work through. You're working through them on your own now. But it looks like they're all perimeter for the most part here. Oh, and then you get to work through finding factors and multiples. Remember, this is how we started the whole lesson. Really being able to define and remember what those factors and multiples are. So tell whether each of the following numbers is prime or composite. This is how we started math in the 4th grade. The number 26, think. Well, already you have to think prime or composite. Remember, prime means it only has 2 factors, one in the number itself. That's it. Composite, it has more than 2 factors. It has more than 1 factor pair, if you will. So the number 26, I know right away, you guys, 1 and 26. 1 and 26 are factors, but it's an even number. So you take 2 times 13, and that's another factor pair. So it has 4 factors. We call that number composite. B, 46. 46, again, is an even number that's above 2. So it's going to have multiple factor pairs. For example, 1 times 46, 2 times 23. Does it have 4? 4, no. No, 4, 5, 6. Anyway, composite. And so on and so forth. But this one's odd, so you got to think, are there really any other factor pairs than 1 and 97? That one could be prime. Think deeply about it. And then, you guys, they want you to write all the factor pairs for each of the following numbers. So 34, you're thinking, what are all the factors of 34? And I always start, this is where I'm going to do like what we used to do, the rainbow for it. So 1, and 34. That's one factor pair. 2 and 17. That's another one. And then I don't think 3, 4, 5, 6. I think that's it. But if you remember the rainbow we did, that really helped us with factors and factor pairs. So moving on through your work, I believe that's it. So let me go down just a little bit here. Let's make sure you guys, let's just look at number 4. Super quick before I let you go and practice the work. But number 4, the area of a large rectangular rug is 54 square feet. List all the possible pairs of dimensions for the rug. Think about this. All you're doing, you guys, is deciding what are the factor pairs of 54. You could do 6 and 9, because 6 times 9 equals 54. My marker isn't aligned. But 6 times 9 is 54. So you got to think through. I'm going to tell you right now, 2 times something is going to work, and I don't want to give you all the answers. Oh boy. But that is the lesson for today. So you guys, again, factors, multiples, ignore the phone, factors, multiples, dimensions, work backwards, don't give up, and know that we miss you guys. I wish I could see you in person, but I hope that helped understand this a little bit more. If you're confused at all, go back and watch it again. And whatever you do, know that you guys, all the work you're putting in, it's moving you forward. You don't need us right next to you to do it. You've got this. It's worth it. Get it. Keep moving forward, and hopefully we'll see you soon. Bye, you guys.